In the previous modules, we first discussed the tool from the designer's perspective. Then we discussed the knowledge representation of the software tool concept. In addition, an essential aspect of this knowledge-based system is to keep the knowledge base up to date and to offer a large enough amount of relevant data. In this module, we will give you a short overview of the tool functions, user actions and interactions that are needed in this knowledge engineering part of the software. As already told before, the knowledge increases on the one hand by using the tool, because the software automatically saves the result of the trade-off calculation to the knowledge base. In addition, there should also be a possibility to add information manually. The goal of these so-called knowledge engineering stakeholders is to add, change, remove, and update data in the database. These actions of keeping the system up to date are very important for the further existence and use of the tool, since the system's success depends on the number of cases and on the up-to-dateness of the cases. This implies that the first important consideration is to know who has the right to add, remove and change the cases. Ideally, we would like to automate the process because no human action would be needed, and the system can live on its own. Unfortunately, this is utopia. Hence, several categories of people should be considered, such as administrators, energy-saving experts, suppliers, DIY people, and product designers. Meanwhile, we should also consider what rights they have to add changes in the database in order to assure the reliability of the data. Our suggestion is that this reliability problem can be solved by using different levels of access, having a low-level open access platform and a higher-level platform focusing on professional users. The low-level platform should focus on DIY users, which want to make their own bought products more energy efficient without investing in new ones. They should be able to use a platform for free by returning their own comments and experiences to update and adapt the database. The higher level platform focuses on professional users and contains only reliable knowledge, which is not free of charge. Another conflict can be reduced this way, is the problem of the security of the system in contrast to the usability, since too much security will lower the usability of the tool. But to be more concrete, we will continue the further part of our explanation, discussing how James, who is a knowledge engineer user, can interact with the knowledge engineering part of the software. We will show the tool functions and the user actions through the interaction between the software tool and the user. Again, the overall principle of organizing the interaction was based on the understanding that an interaction is only efficient if controlling the system and inputting the information needs a minimal number of user interactions. And again, we conceived that the interaction with the user happens through a standard computer screen using a mouse and keyboard in the first testable version of the tool. We will show you how James will insert a new case into the database. To be more specific, we have to mention that James is an expert in energy saving and his task is to share his knowledge with others. To follow the whole process of interaction, let's have a look at James's screen and see what happens. To launch the software, James presses just one button. In the opening screen of the system, James goes to the knowledge engineering part and logs in. He types in his username and his password and clicks on the login button. Since James is not a DIY user but has professional skills, he has more rights to change existing cases. On the next screen, James gets multiple options to insert data. In short, he can add a new case, remove or change existing cases, and search in the cases. In this case, James found an interesting manner of saving energy in a coffee maker, by using the principle that it only boils the requested amount of liquid that is needed, in contrast to other coffee or water boiling appliances, which often cook too much. So he decides to open a new case to add the information. On the right part of the screen, multiple fields need to be filled, which are neatly classified into 3 categories: product information, energy saving solution information, and the information of the result of applying these savings to the product. We have to note that not all information must be filled in, but James knows that the more concrete and detailed information he can give, the better his case will be understood and his solution applied in other products. If all information is filled in, the data is uploaded into the knowledge base. Based on what we presented in this abstract prototyping movie, we conclude as follows. The tool is a knowledge-intensive software package with dedicated case bases. There are 3 main stakeholders who are involved in the use of the tool: product designers, software programmers, and knowledge engineers. The problem solving, that is, finding effective and feasible solutions for energy saving with household appliances using ubiquitous controllers, is done in the symbiosis of action of the designers and the actions of the tool. The tool is used interactively and not intended to solve the design problem automatically. The tool offers cases and decision-enabling information for the designers, but the ultimate decision-making is left to the designer. So the knowledge base is established on the case-based reasoning principle, so that every case contains a problem part, which is the product information, and a solution part, which is the solution information and the result information. And finally, knowledge engineers are needed to update and make the knowledge base fully operational.